So if we take this example question, so we've got, if Jordan eats 5/12 of a cake, Sally eats then 3/7 of the remaining amount of the cake, and then Sean eats half of the remaining cake after that, what fraction of the cake remains uneaten at the end? So the most common kind of approach to this would be to multiply each of the fractions by multiplying the numerators together, then multiplying the denominators, and then simplifying from there. The issue with that is going to be that you'll end up with some really large numbers, and if you're working quickly and without a calculator, this is where either mistakes can happen or you might just get a little bit stumped by it as well. So what we can do is we can actually diagonally cancel out numbers as we multiply fractions. This only applies when we're multiplying. We can't do this when we're adding or subtracting. So the first trick in the question is that we're dealing actually with what's remaining, but the fractions that we're given is what was eaten. So when Jordan eats 5/12 of the cake, that implies that the other remaining 7/12 are left behind. So we have 7/12 left. Then Sally then eats 3/7 of that, meaning that she leaves behind 4/7 of that fraction. And then after that, we've got Sean, who then eats half of that remaining 4/7. So he leaves behind another half as well. So his is going to be half. Now remember, these are the leftovers. So the next thing is with fractions, with any kind of calculation, you can often summarize it in a sentence. So in this case, we could think of it as being the amount remaining is half of 4/7 of 7/12. And the word of, we can translate into the symbol times. So with multiplication, the order doesn't matter. So half times 4/7 times 7/12, we can do it in this order as well. And so this is where the trick comes in. A lot of people would do 7 times 4 is 28 times 1, end up with 28. And then 12 times 7 being 84, and then times 2 and then getting 168. But then you have to go through and simplify that fraction. It's going to be a bit of a nightmare. So what is actually a whole lot easier is if we look diagonally, we can find pairs. So for example, 7 and 7 there, they can cancel out as long as one's on the top and one's on the bottom. And then we can also simplify the 2 and the 4. But I'm going to go with the 12 and the 4 just because the 12 is a larger number. And that way then we can keep our numbers small. So we can divide 4 and 12 both by 4. So this would have 4 go in once, and then 4 goes into that 3 times. We then look if there's any other pairs that we can line up that have similar factors, but there aren't at this point. But the difference is now that we have much simpler numbers. So across the top, we now have 1 times 1 times 1, which is obviously 1, and then 3 times 1 from this 7 that's cancelled out. And then, so 3 times 1, and then times 2, which is 6. And so after all of that, it ends up actually just being 1/6. Now, if we went back to that 28 over 168, I believe it was, we could then find that 28 does go into 168 exactly 6 times. So it does simplify to the same answer, but it means you don't have to deal with really large numbers.